Welcome to 10 minutes CS. 2530 maximal score after applying key operations. You are given a zero indexed integer array nums and integer k. You have a starting score of 0. And in one operation, either we can choose an index I such that it lies in the range of the array and increase the score by that element and replace that element with the seal of number divided by 3. We need to return the maximal possible score we can attain after applying exactly k operations. The ceiling function is defined as the least integer greater than or equal to the value. So let's say we divide 10 by 3, that will be 3.33 something. So the seal value for it will be 4. If we let's look at the examples, we are given a nums array 10, 10, 10, all 10s and k equal to 5. We can apply the operation to each array element exactly once and get the final score as 50. So let's say we apply the operation at this one. So this will be replaced by 4. Now as we can only apply maximum k operations, and to increase the score or maximize the score, we should take the maximal of all these elements. So we can take the next 10 and then reduce it by 4. Now the maximum of it will be 10, so we can take this 10, now this 10, now this 10. By now we have exhausted our k value, so our final score will be 50. Now let's look at this. Here we have got the maximal, which is 10. We replace it by 4 and initially our score was 0, so we added 10 to it. Now among these the maximal is 4, so we add 4 here and it becomes 2 after applying the seal operation. And among these our maximal is 3. We can take either of these 3, so let's say we took this one, and by now we have exhausted our k value, so the sum of all this will be 17. Few findings while doing the dry runs was, we should always take the max of all the elements in our array. Let's think of a brute force approach for this one. So we can apply operations k times, right? So we can run a while loop till our k is greater than 0, and for each operation we can find the max in our array by applying a for loop. And once we have found that index I, let's say this function gives us the index I, we can add it to our score, which was initialized with 0. We can add it here, nums at I, and then we can update nums at I by math.seal of nums at I divided by 3. And we keep on doing this unless we have exhausted our k and finally return our score. So what is the time complexity for this operation? We are doing this operation k number of times, and each time we are running an inner for loop for finding the maximum. So it will be k into n. Can we do better with this? What are we trying to find with this for loop? We surely have to apply the operations k times, so we can't improve on this. But can we get the find operation in a better time complexity than n? So what is that data structure which helps in finding the maximum or minimum among the elements? That is heap data structure. So we can use a heap or a priority queue to find this, and this will significantly reduce it to log of n. So just that we run that while loop, but instead of this running a for loop, we can do pq dot poll, we can define our priority queue as a max heap by defining a lambda function within it. And once we have poll, we can add our poll value to it, and instead of updating the element, we can update the priority queue value by doing priority queue dot add, and we can add this mat.seal of our I divided by 3. So we can find the seal of any value by, like, so this time it was 3, so we can add 2 to it and divide by 3. Let's look at the code. We define our score as long score 0. As a return type is long, we define a priority queue as a max heap, and we add all the elements to our priority queue. We run a while loop unless we have exhausted our k values. We poll the value from the priority queue which give us the current max, and we add it to our score, and finally we again add it to our priority queue the seal value of it. This is exactly same as finding the seal of current max divided by 3, and finally we just return score. So as we are adding the elements here, all the elements, so the complexity will be O of 1 n here, and here the complexity will be k into this will log of n. So the overall time complexity will be k into log of n, and the space complexity will be big O of n, as we need to add all the elements to our priority queue. Hope you like the video. Thank you for watching.